years of galaxies, stars, and untold mysteries. What's really wild is that this Great Wall doesn't fit neatly into the theories we have about how the universe is structured. According to the cosmological principle, the idea that the universe is uniform on the largest scales, something this big shouldn't even exist. Its discovery has forced scientists to rethink the rules of the game. Why would matter arrange itself into something so immense? What forces could shape such a structure? It's like the universe decided to flex its creative muscles and say, "Think you've got it all figured out? Guess again." But the Hercules Corona Borealis Great Wall isn't just a jaw-dropping factoid. It's a portal to bigger questions. It's a reminder of how much we don't know about the universe. Structures like this aren't just about their size. They're about the story they tell. They hold clues to the early days of the universe, the mysterious forces shaping it, and maybe even the future of everything we know. So next time you look up at the stars, remember, somewhere out there, far beyond what we can see, lies a wall so vast it redefines what we thought was possible. Mind-blowing, right? The cosmic microwave background. Take a moment to imagine the faintest whisper of a story, left over from the very birth of the universe. That is the cosmic microwave background, or CMB for short. It is not just any light, it is the oldest light in existence, a relic from a time when the universe was just 380,000 years old, a baby, cosmically speaking. This faint glow is everywhere in the sky, a subtle reminder of the Big Bang that kick-started everything we see today. It is like holding a photograph of the universe as an infant, showing us what things looked like before galaxies, stars, and planets even existed. Now here is where it gets exciting. This glow is not uniform. It has tiny variations, little ripples in its temperature, that tell us where the seeds of galaxies and clusters formed billions of years ago. Think of it like cosmic breadcrumbs, showing the early layout of the universe. When scientists mapped these variations using missions like WMAP and Planck, they unlocked a treasure trove of information. It is through these maps that we learned about the universe's age, its composition, and how much of it is made up of mysterious things like dark matter and dark energy. Can you believe that a faint glow in the sky holds answers to some of the biggest questions in cosmology? What makes the CMB truly incredible is its universal presence. No matter where you look in the sky, this ancient light is there. It connects everything, every star, galaxy, and atom, to a single origin. It is humbling to think that this glow has traveled for over 13 billion years, untouched and uninterrupted, just to reach us. And the best part? It is still teaching us new things. Every time scientists look deeper, they discover more clues about the universe's early days and the forces that shaped its evolution. At the end of the day, the cosmic microwave background is more than just an astronomical phenomenon. It is a time capsule, a glimpse into the universe's fiery beginnings, and a reminder of how interconnected everything truly is. So the next time you stare up at the night sky, think about this. That glow is not just the stars or the Milky Way. It is the universe's first light, still echoing through the cosmos, carrying the story of how everything began. Amazing, right? The Sloan Great Wall. Picture a wall in the cosmos so massive it would take light over 1 billion years to travel across it. That is the Sloan Great Wall, one of the largest cosmic structures ever discovered. It is not a wall in the traditional sense, but a sprawling chain of galaxy clusters, filaments, and voids woven into the fabric of the universe. This awe-inspiring structure stretches over 1.37 billion light-years and completely redefines what we thought was possible when it comes to scale in the universe. What makes the Sloan Great Wall so fascinating is how it was uncovered. Astronomers mapping the positions of galaxies through the Sloan Digital Sky Survey stumbled upon this enormous arrangement, almost by accident. Imagine zooming out on a cosmic map and suddenly seeing this intricate network of galaxies connected like threads in a spider's web. The discovery was groundbreaking. It showed us that galaxies do not randomly scatter throughout space. Instead, they follow patterns shaped by gravity and the mysterious forces of dark matter. You might be wondering why this giant cosmic wall is such a big deal. Here is the thing. It challenges one of the fundamental ideas about the universe, the cosmological principle. This principle says the universe should look more or less the same on a large scale, no matter where you look. But something as colossal as the Sloan Great Wall seems to defy that idea. How could such a massive structure exist without breaking the rules of cosmic formation? It forces scientists to rethink how the universe organizes itself and raises fascinating questions about the very nature of reality. When you think about it, the Sloan Great Wall is not just a scientific discovery. It is a reminder of how vast, interconnected, and mysterious the universe truly is. It is proof that even the biggest questions do not have easy answers and that there is always more to learn. So the next time you hear about the mysteries of space, remember that structures like this one are waiting out there, quietly holding secrets about the cosmos. Mind-blowing, isn't it? The Virgo supercluster. Think about this for a moment. The Milky Way, our galactic home, is just one of countless galaxies nestled within an immense cosmic structure called the Virgo supercluster. Stretching roughly 110 million light-years across, this supercluster is our celestial neighborhood, a vast network of galaxies all bound together by gravity. It is where we belong in the grand cosmic web, and understanding it gives us a deeper connection to the universe itself. What is so cool about the Virgo supercluster is how it influences the motion of galaxies, including our own. At its heart lies the Virgo cluster, a dense hub of thousands of galaxies with a gravitational pull so strong that it dictates the paths of galaxies even millions of light-years away. Picture an intricate dance where galaxies move in complex patterns, all choreographed by the gravity of this massive cluster. Our own Milky Way is part of this grand movement, heading toward a region known as the Great Attractor, another mysterious point of gravity in our universe. One of the most fascinating things about studying the Virgo supercluster is how much it has taught us about the invisible side of the universe. When scientists map the motions of galaxies, they can detect the presence of dark matter, the unseen substance that makes up most of the universe's mass. The Virgo supercluster is like a giant lab, helping us uncover the secrets of how dark matter shapes cosmic structures. Without dark matter, none of these incredible formations, from galaxies to superclusters, would exist. In the end, the Virgo supercluster is more than just a collection of galaxies. It is a reminder that even in the vastness of space, there is a sense of structure and belonging. Our galaxy is part of something far larger, a network of stars and planets bound together across unimaginable distances. So when you look up at the stars, remember you are connected to this colossal supercluster, a tiny piece of a cosmic masterpiece that is still being unraveled. Inspiring, isn't it? The Boots Void. Have you ever thought about what lies in the emptiest corners of the universe? That is where the Boots Void comes in. It is not just empty, it is a staggering 330 million light-years of near-total nothingness, earning it the nickname the Great Nothing. When astronomers first discovered it, they were stunned. How could a region of space so vast have so few galaxies, when the rest of the cosmos seems packed with them? It is a mystery that still sparks debates and theories to this day. What makes this void so puzzling is how much it breaks the pattern of the universe. Space is not supposed to be perfectly uniform, but it is typically filled with clusters of galaxies connected by filaments, all forming the intricate cosmic web. Yet the Boots Void is almost completely empty, with only a handful of galaxies scattered across an area that could normally hold tens of thousands. It is as if the universe just decided to take a break here, leaving behind an eerie void of unimaginable size. The best part about the Boots Void is how it challenges everything we thought we knew about galaxy formation. Scientists believe voids like this are created when regions of space run out of material to form stars and galaxies. But the sheer size of this one suggests there is more to the story. Some even speculate about exotic explanations like alternative physics or phenomena we have yet to discover. It is like the universe's version of a blank canvas, inviting us to imagine what might exist or not exist within its depths. What is really fascinating is how the Boots Void reminds us of the universe's diversity. While we are amazed by clusters of galaxies and grand cosmic structures, voids like this one are just as important. They shape the web of the universe and tell us that even emptiness has a role to play in the grand design of space. So the next time you hear about the mysteries of the cosmos, think about the Boots Void, a silent and enigmatic stretch of space that keeps us questioning and searching for answers. Amazing, right? The Laniakea supercluster. Can you imagine the sheer size of the cosmic neighborhood we call home? Let me introduce you to the Laniakea supercluster, a structure so vast it redefines what we call home in the cosmos. This supercluster contains around 100,000 galaxies, including our Milky Way, and stretches over 520 million light-years. The name Laniakea, which means immeasurable heaven in Hawaiian, perfectly captures the breathtaking enormity of this region. It is the very definition of cosmic scale. What makes Laniakea truly special is how interconnected it is. Think of it as a sprawling network of galaxies flowing like rivers along invisible filaments of gravity. At the heart of this supercluster lies a gravitational basin called the Great Attractor, a region pulling everything toward it, including our galaxy. When scientists mapped Laniakea in 2014, they used the motions of thousands of galaxies to trace the edges of this colossal structure. What they found was a massive web where everything was drawn toward this central point, creating a cosmic dance of unimaginable proportions. Here's where it gets even cooler. Laniakea is not just a single, isolated structure. It is part of the larger cosmic web, where superclusters like Laniakea are interconnected across billions of light-years. This means that our supercluster is just one thread in the universe's grand tapestry. By studying how galaxies move within Laniakea, scientists have gained insights into the mysterious forces shaping the universe, like dark matter and dark energy. It is like unraveling the secrets of the cosmos one step at a time. When you step back and think about it, Laniakea is more than just a collection of galaxies. It is a reminder of how small we are in the grand scheme of things, yet how connected we are to something much larger. Our Milky Way is part of this enormous supercluster, tied together with countless other galaxies, all moving in harmony. It is a stunning example of the beauty and complexity of the universe. Mind-blowing, isn't it? The cosmic web itself. Let's take a step back and think about the universe on the biggest scale possible. The cosmic web is exactly that, the largest structure in existence, connecting galaxies, clusters, and superclusters across billions of light-years. Picture a three-dimensional web stretching out in every direction, with luminous threads where galaxies gather and vast empty voids in between. This is the very framework of the universe, the invisible scaffolding that holds everything together. What makes the cosmic web so fascinating is how it was formed. It all started after the Big Bang, when tiny fluctuations in the early universe grew over time under the pull of gravity. Dark matter, the mysterious substance we still do not fully understand, played a huge role in shaping this web. Galaxies formed along these dark matter filaments like beads on a string, while the spaces between them stretched into massive voids. When you think about it, this web is like the universe's fingerprint, a unique and intricate design that tells the story of how everything we see came to be. You might wonder how we even know this web exists. Thanks to incredible advances in technology and simulations, astronomers have been able to map the cosmic web by tracking the distribution of galaxies and the gas that fills the spaces between them. One way they do this is by studying quasars, the super-bright centers of distant galaxies. As light from these quasars passes through the universe, it interacts with hydrogen gas in the web, leaving behind clues about the web's structure. It is like piecing together a puzzle that spans billions of light-years. When you think about the cosmic web, it is not just an abstract idea. It is a profound reminder of how connected everything truly is. Every galaxy, every star, and every planet is part of this vast and intricate network, shaped by forces that have been at work for over 13 billion years. It is the ultimate proof that the universe is not random but carefully organized on scales so massive they boggle the mind. As we conclude our journey through the 7 wonders of the cosmic web, we're reminded of the universe's awe-inspiring beauty and complexity. These celestial marvels push the boundaries of our knowledge and fuel our curiosity to explore the unknown. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. Have you ever gazed up at the night sky and wondered what bizarre, otherworldly places might be out there? The universe is filled with exoplanets so strange and extreme that they defy imagination. From planets hotter than stars to worlds made entirely of ice, these discoveries redefine what we thought was possible. Join us as we take a journey to explore the 10 strangest exoplanets discovered so far. Each one will blow your mind, so stick around and let's dive into the cosmos together. Kelt 9b, a scorching inferno. Meet Kelt 9b, a planet so blisteringly hot it challenges the boundaries of planetary science. Orbiting a star twice as hot as our Sun, this gas giant experiences daytime temperatures exceeding 7,800 degrees Fahrenheit. That's hotter than some stars. The extreme heat has stripped the planet of its atmosphere's molecules, breaking them down into their basic atomic components. This planet orbits so close to its host star that a year lasts only about 1.5 days. Its proximity causes it to be tidally locked, meaning one side is perpetually facing the scorching star while the other remains in darkness. Scientists speculate that the night side might be slightly cooler, but cooler is relative when the entire planet is engulfed in unrelenting heat. What makes Kelt 9b even more extraordinary is that it's gradually evaporating. The intense radiation from its star is blowing its atmosphere away into space, creating a glowing tail, much like a comet. This phenomenon provides astronomers a rare glimpse into atmospheric escape, a process that's reshaping our understanding of planetary evolution. Traveling to Kelt 9b isn't an option, it's inhospitable beyond imagination, but studying it reveals how diverse and extreme planets in our universe can be. It's a fiery example of how exoplanets push the limits of what we consider possible in the cosmos. Gliese 436b, the ice on fire world. Gliese 436b seems like a contradiction of nature. Imagine a planet covered in burning ice. Located about 30 light-years away, this Neptune-sized world defies expectations with its bizarre mix of heat and ice. Its surface temperature is a scorching 800 degrees Fahrenheit. Yet water exists as a solid ice mantle, compressed by the planet's immense gravity. This scorching world has a thin atmosphere, primarily composed of hydrogen, helium, and methane, which traps heat. Despite the intense temperatures, the high pressure on the planet keeps water locked in a strange, solid state called hot ice. This exotic form of water remains stable even under extreme heat, an incredible reminder of how physics behaves differently in alien worlds. Adding to the intrigue, Gliese 436b completes an orbit around its host star in just 2.6 Earth days. This tight orbit means the planet is exposed to constant stellar radiation, which further accentuates the paradox of its fiery, ice-covered surface. This otherworldly discovery shows how diverse exoplanets can be, challenging our understanding of what's scientifically possible. Gliese 436b is a testament to the universe's endless creativity, blending fire and ice in a way that can only exist far beyond our solar system. HD 189733b, the glass rain planet. Known as Osiris, HD 209458b is a gas giant slowly being ripped apart by its parent star. Located 150 light-years away, this exoplanet is losing its atmosphere to space at an astonishing rate due to its proximity to its host star. It's a perfect example of a hot Jupiter, a gas giant orbiting extremely close to its star. Osiris experiences extreme ultraviolet radiation that heats its atmosphere, causing hydrogen and helium to escape into space. This process forms a massive tail of gas trailing behind the planet, making it resemble a comet more than a traditional planet. This tail stretches thousands of miles and offers a fascinating glimpse into planetary disintegration. Astronomers have even detected heavier elements like oxygen and carbon in the escaping atmosphere. This discovery is groundbreaking, as it allows scientists to analyze the chemical composition of an exoplanet's atmosphere in detail. The fate of Osiris provides an eerie glimpse into the potential endgame for other exoplanets orbiting too close to their stars. It's a powerful reminder of the delicate balance planets must maintain to survive the harsh realities of space. Kepler 16b, the Tatooine planet. Kepler 16b is a real-life version of Tatooine from Star Wars, a planet that orbits not one but two stars. This celestial oddity is located about 200 light-years away and is a gas giant roughly the size of Saturn. its dual suns create a surreal, ever-changing skyline that alternates between single and double sunsets. The planet lies in a circumbinary orbit, meaning it revolves around both stars as they dance together in a cosmic waltz. Despite its dramatic skies, Kepler-16b is surprisingly cold, with temperatures averaging around -100 degrees Fahrenheit. This chill is due to the distance from its host stars, which provide just enough light to illuminate its surface without warming it significantly. Kepler-16b's discovery confirmed that planets can form and survive in binary star systems, a finding that expands the possibilities for where planets might exist in the universe. This revelation has inspired scientists to explore the dynamics of binary systems further, opening the door to more discoveries in the future. Though uninhabitable, Kepler-16b sparks the imagination with its resemblance to science fiction worlds. Its existence proves that the universe holds surprises beyond anything we could dream up in fiction. 55 Cancri E, the lava world. 55 Cancri E is a planet of extremes. Found 41 light-years away in the Cancer constellation, this rocky super-Earth is locked in a perpetual furnace. With one side permanently facing its star, the planet experiences temperatures soaring over 4,400 degrees Fahrenheit. On the other side, where starlight never reaches, temperatures plummet drastically, creating a world of stark contrasts. This hellish planet is theorized to have rivers of lava flowing on its day side. Its surface glows with molten rock, illuminated by its blistering star. Scientists also suspect that the planet's atmosphere is dense with vaporized minerals, adding to its fiery ambience. The interaction between the extreme heat and the planet's unique geology creates an environment where lava oceans could exist, constantly churning and reshaping the surface. What makes 55 Cancri E even more captivating is its unusual orbit. A year on this planet lasts only 18 Earth hours, meaning it hurtles around its star at breakneck speeds. The extreme proximity to its host star also causes significant tidal heating, contributing to its molten state and making it an active and volatile world. As bizarre as 55 Cancri E sounds, its study offers scientists valuable insights into planetary formation under extreme conditions. This lava world is a testament to how planets can evolve into scorching wastelands that challenge our perceptions of habitability. WASP-12b, the planet being consumed. WASP-12b is a doomed world, slowly being devoured by its host star. Located about 1,400 light-years away, this gas giant orbits perilously close to its star, completing an orbit in just over one Earth day. Its proximity subjects the planet to immense gravitational and radiation forces, causing its atmosphere to stretch and form an elongated shape rather than the typical spherical form of planets. The intense radiation from the star heats WASP-12b to temperatures around 4,000 degrees Fahrenheit, making it one of the hottest known exoplanets. This heat has caused the planet's outer layers to expand and leak into space, forming a trail of escaping gases. Essentially, WASP-12b is being consumed alive, losing about 189 quadrillion tons of material every year. Astronomers studying this phenomenon have likened it to a celestial version of vampirism, where the host star is draining the planet of its lifeblood. Over time, this will result in WASP-12b being entirely obliterated, leaving nothing but a ghostly ring of debris around the star. This dramatic process offers a rare glimpse into planetary destruction, a stage in the life cycle of planets that's difficult to observe directly. WASP-12b's tragic fate reminds us of the fragile balance planets must maintain to survive the harsh realities of space. TRES-2b, the darkest planet. TRES-2b, located about 750 light-years from Earth, is often called the Black Planet due to its astonishing ability to absorb light. This gas giant reflects less than 1% of the starlight that hits it, making it darker than coal. Despite being bathed in the light of its host star, the planet remains eerily dark, with only a faint red glow caused by its internal heat. The reason for TRES-2b's darkness lies in its unusual atmosphere, which lacks reflective clouds and is rich in light-absorbing chemicals like titanium oxide. These compounds trap heat and light, giving the planet its pitch-black appearance. The lack of an atmosphere capable of scattering light further enhances its shadowy nature. Although it's cloaked in darkness, TRES-2b is incredibly hot, with temperatures soaring to over 1,800 degrees Fahrenheit. The stark contrast between its searing heat and its inky blackness makes it one of the most intriguing exoplanets ever discovered. Scientists are still unraveling the mystery of why TRES 2b is so exceptionally dark. Studying it could provide insights into atmospheric compositions and help identify similar worlds in the future. TRES 2b is a haunting reminder of how alien and diverse planets beyond our solar system can be. PSR B16 2026b Methuselah, the ancient planet. Nicknamed Methuselah for its incredible age, PSR B 162026b is the oldest known planet in the universe, with an estimated age of 12.7 billion years. That's nearly 3 times the age of Earth. Orbiting a binary system composed of a pulsar and a white dwarf, Methuselah is located in the globular cluster M4, about 12,400 light-years away. This gas giant challenges everything we know about planetary formation, as it emerged when the universe was less than 1 billion years old and lacked many of the heavier elements needed to form planets. Its existence suggests that planets can form under a broader range of conditions than previously thought. Methuselah's orbit around its host stars is both stable and extraordinary, taking about 100 Earth years to complete. This leisurely pace offers scientists a fascinating opportunity to study the gravitational interactions within its unique binary system. Despite its ancient origins, Methuselah is a robust planet that has endured countless cosmic events, including nearby supernovae and the gradual aging of its host stars. It's a true survivor, offering a window into the universe's earliest days. HD 189733b, the Glass Rain Planet. HD 189733b, a stunningly violent world, is located 64 light-years away in the constellation Vulpecula. This gas giant has an atmosphere dominated by silicate particles, which condense to form clouds of molten glass. The result is a planet where it literally rains glass, blown sideways by winds exceeding 5,400 miles per hour. The planet's deep blue hue, similar to Earth's oceans, is caused by the scattering light of these silicate particles. However, the similarities to Earth end there. With surface temperatures reaching a scorching 1,700 degrees Fahrenheit, HD 189733b is a hostile and volatile world. The extreme winds and glass rain are driven by the planet's tight orbit around its host star, which is completed in just over 2 Earth days. This proximity subjects it to intense radiation and tidal forces, fueling its chaotic weather patterns. HD 189733b is a prime example of how alien and extreme weather can get on exoplanets. Studying this world offers scientists clues about atmospheric dynamics and helps refine techniques for detecting similar phenomena on distant planets. Ogle 2005 BLG 390lb, the coldest planet. Ogle 2005 BLG 390lb, located a staggering 21,500 light-years away, is one of the coldest exoplanets ever discovered. Dubbed the Hoth planet after the icy world in Star Wars, this frozen super-Earth exists in the far reaches of its host star's habitable zone. With surface temperatures plummeting to -370 degrees Fahrenheit, it's a desolate, icy wasteland. This frigid planet orbits a faint red dwarf star, which provides little heat and light. The planet's vast distance from its star results in an extremely long orbital period, taking about 10 Earth years to complete one revolution. Despite its cold environment, Ogle 2005 BLG 390lb's discovery was groundbreaking, as it was one of the first planets detected using gravitational microlensing. Its icy surface suggests that it could potentially harbor frozen water, sparking curiosity about its composition and the possibility of life beneath its frozen crust. While unlikely to be habitable, studying Ogle 2005 BLG 390lb has expanded our understanding of where planets can exist and thrive. This frozen world highlights the incredible range of environments exoplanets can offer, proving that even the most inhospitable conditions can yield fascinating discoveries. And there you have it, the 10 strangest exoplanets discovered so far. Each of these alien worlds challenges our understanding of the universe and expands our imagination. If you enjoyed this cosmic journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the extraordinary wonders of space. Ever wondered what makes Venus one of the most fascinating planets in our solar system? From its mysterious backward spin to its surface temperatures that could melt lead, Venus is a world of extremes and surprises. Did you know it's considered both Earth's twin and a potential warning about our planet's future? Join us as we uncover 10 mind-blowing facts about Venus, exploring the secrets of this enigmatic world and what it tells us about our place in the cosmos. Venus rotates backward, a planet in reverse. Venus does something truly unusual. It spins backward compared to most planets in the solar system. While Earth rotates on its axis from west to east, Venus spins from east to west. This retrograde rotation means the sun rises in the west and sets in the east on Venus, a concept that's hard to imagine for those of us used to Earth's patterns. The reasons for this backward spin remain a cosmic mystery. Scientists theorize that a massive collision with an asteroid or protoplanet during Venus's formation may have flipped its axis. Another possibility is the influence of gravitational forces from the Sun and other planets, gradually altering its spin over billions of years. What's even more fascinating is that a day on Venus is longer than a year on Venus. It takes about 243 Earth days for Venus to complete one rotation on its axis, but only 225 Earth days to orbit the Sun. This creates a bizarre dynamic where the planet's surface experiences incredibly long periods of daylight and darkness, leading to extreme environmental conditions. Venus's slow and backward rotation contributes to its thick, stagnant atmosphere, as the planet lacks the Coriolis effect that creates dynamic weather patterns on Earth. This strange spin offers clues about the chaotic early days of planetary formation and how celestial collisions can shape a world's destiny. Venus is the hottest planet in the solar system. Despite being the second planet from the Sun, Venus is the hottest planet in our solar system. Its surface temperatures reach a staggering 900 degrees Fahrenheit, hot enough to melt lead. This intense heat is caused by a runaway greenhouse effect, where Venus's thick atmosphere traps solar energy and keeps the planet perpetually scorching. The atmosphere of Venus is primarily composed of carbon dioxide, with clouds of sulfuric acid reflecting sunlight. Instead of cooling the planet, this creates a heat-trapping cycle that has turned Venus into an inferno. Even spacecraft that have landed on Venus could only survive for a few hours before succumbing to the extreme temperatures and crushing pressures. What's intriguing is that Venus may have once been much cooler and possibly even supported liquid water on its surface. Some researchers suggest that billions of years ago, Venus might have been Earth-like, with conditions that could have supported life. However, as the planet's greenhouse effect intensified, its oceans boiled away, leaving the barren, hostile world we see today. Venus serves as a stark reminder of the power of greenhouse gases and the potential consequences of climate change. By studying Venus, scientists hope to gain insights into Earth's atmospheric dynamics and how to prevent a similar fate on our planet. Venus has super-rotating winds. Beneath its serene appearance, Venus is home to some of the most extreme weather conditions in the solar system. The planet's thick atmosphere is whipped into a frenzy by super-rotating winds that reach speeds of up to 250 miles per hour. These winds circle the planet in just 4 Earth days, far outpacing Venus's sluggish rotation. The phenomenon of superrotation is not fully understood, but scientists believe it's driven by a combination of solar heating, the planet's dense atmosphere, and its slow rotation. The winds are strongest in the upper atmosphere, creating a high-speed jet stream that encircles the planet. Near the surface, however, the winds slow down significantly, creating a much calmer environment. These winds also drive the movement of Venus's thick cloud layers, which are composed of sulfuric acid droplets. The clouds reflect sunlight, giving Venus its bright and shining appearance in the night sky. This reflection is why Venus is often called the morning star or evening star, as it's one of the brightest objects visible from Earth. Venus's super-rotating winds challenge our understanding of atmospheric dynamics and highlight how different a planet's weather systems can be from those on Earth. Studying these winds could provide insights into atmospheric phenomena on other planets and even exoplanets beyond our solar system. Venus has no magnetic field. Unlike Earth, Venus lacks a significant magnetic field, leaving it exposed to the full force of solar wind and radiation. Magnetic fields are usually generated by a planet's molten core and its rotation, but Venus's slow spin and internal structure prevent it from producing this protective shield. Without a magnetic field, Venus's atmosphere interacts directly with the solar wind, leading to the gradual loss of lighter elements like hydrogen. This loss likely contributed to the disappearance of water on Venus, as solar radiation broke water molecules into hydrogen and oxygen, with hydrogen escaping into space. The lack of a magnetic field has also made Venus a prime target for studying how planets interact with their star. By observing Venus, scientists can learn more about the effects of solar wind on a planet's atmosphere and the conditions that could affect habitability in other worlds. Interestingly, Venus's atmosphere is so thick that it still retains most of its gases despite the absence of a magnetic field. This resilience provides a stark contrast to Mars, which also lacks a magnetic field but has a much thinner atmosphere. The differences between Venus, Earth, and Mars highlight the complex interplay of factors that shape a planet's evolution. Venus's surface is a volcanic landscape. The surface of Venus is dominated by volcanic features, making it one of the most geologically active planets in the solar system. Over 80% of Venus's surface is covered in volcanic plains, with vast lava flows, towering mountains, and massive calderas. Venus is home to some of the largest volcanoes in the solar system, including Mont Mons, which rises nearly 5 miles above the surrounding plains. Unlike Earth, where volcanic activity is driven by tectonic plate movements, Venus's volcanism is thought to result from upwelling plumes of molten rock beneath its crust. Recent studies suggest that Venus may still be volcanically active today. Observations from spacecraft have detected changes in the planet's surface temperature and composition, hinting at ongoing eruptions. This activity could be responsible for the sulfur dioxide variations observed in Venus's atmosphere. The volcanic landscape of Venus offers a window into the planet's geologic history and provides clues about its internal structure. By studying Venus's volcanoes, scientists hope to better understand the role of volcanism in shaping planetary surfaces and atmospheres. Venus's fiery surface is both a testament to its violent past and a reminder of the dynamic processes that continue to shape our solar system. Venus's atmosphere is a crushing hellscape. The atmosphere of Venus is a place of unimaginable extremes, making it one of the most hostile environments in the solar system. Composed primarily of carbon dioxide with traces of nitrogen and sulfur dioxide, this thick atmosphere creates pressures 92 times greater than Earth's at the surface. It's equivalent to being nearly a mile underwater on Earth. The crushing pressure isn't the only challenge. The atmosphere contains clouds of sulfuric acid that blanket the planet, reflecting sunlight and giving Venus its bright appearance. These clouds not only make it impossible to see the surface from space, but also contribute to the planet's searing heat. Despite these extreme conditions, scientists are fascinated by Venus's atmosphere. Some studies suggest that microbial life could exist in the upper cloud layers, where temperatures and pressures are more Earth-like. This possibility has sparked interest in sending more missions to explore the atmosphere and uncover its secrets. Understanding Venus's atmosphere is crucial for planetary science, as it provides a glimpse into what happens when a greenhouse effect goes unchecked. By studying Venus, we gain insights into climate dynamics that could have implications for Earth and other planets. The atmospheric hellscape of Venus is both a warning and a wonder, showcasing the planet's ability to challenge our expectations about what a world can be. Venus once had oceans, but they boiled away. Venus may seem like an inferno now, but evidence suggests that it once had oceans of liquid water. Billions of years ago, Venus's conditions might have been similar to Earth's, with a cooler surface and the potential to support life. As the sun gradually brightened over time, Venus's temperatures rose, causing its oceans to evaporate. The water vapor, a potent greenhouse gas, traps more heat in the atmosphere, creating a runaway greenhouse effect. This led to the boiling away of its oceans and the transformation of Venus into the scorched planet we see today. One of the key pieces of evidence for past water on Venus comes from the ratio of deuterium to hydrogen in its atmosphere. Deuterium, a heavier isotope of hydrogen, is more likely to remain in the atmosphere when water is lost. Venus's atmosphere has a much higher deuterium to hydrogen ratio than Earth's, suggesting significant water loss. Understanding Venus's climatic history is vital for modeling the evolution of habitable environments. If Venus had liquid water and potentially habitable conditions, why did it change so drastically? These questions drive ongoing research and missions aimed at uncovering the planet's past. The story of Venus's lost oceans is a haunting reminder of how fragile habitable conditions can be and how planetary environments can evolve over time. Venus's surface is young and renewed. Unlike the Moon or Mars, which are littered with craters from billions of years of impact, Venus's surface is relatively young, with an average age of about 300 to 500 million years. This youthfulness suggests that the planet undergoes periodic resurfacing events that erase its geological history. The primary mechanism for this resurfacing is thought to be volcanic activity. With no tectonic plates like Earth, Venus's crust may periodically heat up and melt, leading to massive lava flows that cover the surface. This process essentially resets the planet's geological clock, making Venus a dynamic but enigmatic world. Radar mapping from missions like NASA's Magellan spacecraft has revealed a surface covered in vast plains, mountain ranges, and unique features called coronae, which are formed by upwelling plumes of molten rock. These features indicate that Venus's geology is driven by internal processes rather than external impacts. The lack of tectonic plates also means that Venus doesn't have the same mechanisms for recycling carbon as Earth. This contributes to its runaway greenhouse effect, as carbon dioxide remains locked in the atmosphere instead of being absorbed into the crust. Venus's young surface tells a story of continuous renewal, highlighting how volcanic activity can shape a planet in ways that are both similar to and vastly different from Earth. Venus shines brightest in the sky. Venus is often called the morning star or evening star because of its dazzling brightness in the sky. It's the third brightest natural object visible from Earth, after the Sun and the Moon. This brilliance has made Venus a prominent feature in human culture and mythology for thousands of years. The planet's brightness is due to its thick clouds, which reflect about 70% of the sunlight that hits it. Combined with its proximity to Earth, this makes Venus appear incredibly luminous, even to the naked eye. Ancient civilizations often associated Venus with gods and goddesses of love and beauty, like Aphrodite in Greek mythology and Ishtar in Mesopotamian traditions. Astronomically, Venus follows an interesting pattern in the sky. It's visible either just before sunrise or just after sunset, depending on its position in its orbit. Because it stays close to the Sun from our perspective, Venus never ventures far into the night sky, adding to its mystique. This brightness also makes Venus an ideal target for telescopes and spacecraft. Its visibility has inspired countless missions to explore its secrets, from early flybys to ambitious plans for future atmospheric studies. Venus's brilliance reminds us of its enduring presence in our skies, captivating humans for generations and fueling our curiosity about the universe. Venus may hold clues to Earth's future. Venus is often called Earth's twin because of their similar size, composition, and proximity to the Sun. However, the stark differences between the two planets make Venus an essential case study for understanding Earth's potential future. The runaway greenhouse effect on Venus offers a sobering example of what could happen if a planet's atmosphere becomes overwhelmed by heat-trapping gases. As Earth grapples with climate change, studying Venus provides valuable insights into the dynamics of atmospheric warming and the delicate balance needed to maintain habitable conditions. Venus also highlights the role of geological processes in shaping a planet's destiny. With no plate tectonics or magnetic field, Venus lacks the mechanisms that help regulate Earth's environment. This contrast underscores the importance of these systems for maintaining a stable climate and supporting life. By sending missions to Venus, scientists hope to unlock its secrets and learn how two similar planets ended up on such divergent paths. Future explorations like NASA's Veritas and Da Vinci missions aim to study Venus's atmosphere, surface, and geological history in unprecedented detail. The story of Venus is not just about understanding another planet, it's about understanding our own. By comparing Earth and Venus, we gain a deeper appreciation for the factors that make our world unique and the steps we must take to protect it. That wraps up our exploration of Venus, a planet of extremes, mysteries, and profound lessons for Earth. From its scorching surface to its haunting past, Venus challenges us to rethink what we know about the cosmos. If you enjoyed this journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.